Have you ever wondered why some software systems can handle billions of users while others crash with the simplest update? The secret often lies in how the code is organized. In the early days of computing, programs were like long, linear recipes. But as software grew, these recipes became spaghetti code, unmanageable, and prone to breaking. Object-oriented programming, or OOP, changed everything. Instead of focusing on logic alone, it focuses on objects, data, and behavior bundled together. To master OOP, you need to understand its 4 foundational pillars. Let's break them down one by one, starting with encapsulation. Think of encapsulation like a TV remote. You interact with the buttons, the public interface, without needing to touch the complex circuitry inside. In code, this means bundling data and the methods that operate on it into a single unit, while restricting direct access to the internals to protect integrity. The second pillar is abstraction. It's about hiding complexity. When you drive a car, you don't need to understand internal combustion to turn the wheel. In programming, abstraction allows us to show only the essential features of an object, reducing cognitive load and making systems easier to use. Next is inheritance. This allows a new class to inherit properties and behaviors from an existing one. It's the ultimate tool for code reuse. Just as a truck inherits the basic characteristics of a vehicle but adds its own unique features, subclasses build upon their parents without reinventing the wheel. Finally, we have polymorphism, which means many forms. It allows different objects to respond to the same message in their own specific way. A single command like draw can trigger a different action depending on whether the object is a circle, a square, or a triangle. This makes code incredibly flexible. But where did all of this begin? The story starts in the 1960s at the Norwegian Computing Center with Ole Johan Dahl and Kristen Nygaard. They created Simula to model complex real-world simulations like airport traffic, where independent entities or objects needed to interact. In the 70s, Alan Kay at Xerox PARC took these ideas further with Smalltalk. He envisioned objects as biological cells communicating via messages. Smalltalk wasn't just a language, it was the foundation of the modern graphical user interface, the windows, icons, and menus we use every day. If you're finding this helpful, remember that I've curated a list of deep dive resources, research papers, and practice platforms in the description below. Let's look at a practical example in Python. We define a dog class with a name and a breed. These are its attributes. Then we add a bark method. This is its behavior. When we create an instance of this class, we have a unique object that can perform that action. We can create dozens of dog objects, each with different names and breeds, but they all share the same blueprint. This is the power of classes and instances. A frequent mistake for beginners is creating a God object, a single class that does way too much. Remember the single responsibility principle. Another pitfall is deep inheritance hierarchies. They create brittle code where a small change at the top can break everything below. Focus on composition instead. Don't ignore encapsulation. If every part of your program can reach in and change an object's internal state, you lose the ability to guarantee its integrity. OOP is the backbone of modern software. In web development, frameworks like Rails and Django use objects to separate data, logic, and interfaces. It's also essential in artificial intelligence and cloud computing, where complex systems are broken down into manageable, interacting microservices. And in game development, every character, weapon, and item is typically an object, allowing for rich, interactive worlds built from modular components. By now, you should understand the core idea behind OOP, organizing code into modular, self-contained units that interact through clear interfaces. You can now recognize these patterns in real-world systems and start applying these principles to your own programming projects. To truly master these concepts, I encourage you to explore the curated resources in the description, from official documentation to academic papers. Dive into open source projects or try interactive coding platforms to see OOP in action. The best way to learn is by building. OOP isn't just a coding style, it's a way of thinking about the world and solving complex problems. Thanks for learning with me today. Let's take a moment to reflect on the transition. Before OOP, adding a single feature meant searching through thousands of lines. Now you just add a new object. The key takeaway is state management. Objects manage their own state, which prevents the global variable mess that plagued early software engineering. Dahl and Nygaard's Simula 67 was revolutionary because it allowed objects to persist independently of the function calls that created them, using a heap-based system. Alan Kay famously said the big idea was messaging, how objects communicate. Focus on the interfaces, not just the data inside. Even in databases, we use object relational mapping to translate our code objects into rows and columns, bridging 2 different ways of thinking. In networking, packets can be modeled as objects, carrying their own metadata and knowing how to route themselves through complex topologies. The single responsibility principle is your best friend. A class should have one, and only one, reason to change. This is the heart of clean OOP. From simulations in Oslo to the apps in your pocket, object-oriented programming remains the most powerful way to organize human thought in digital form.